Last speaker before lunch, so thank you for your attention. I'm going to be talking about Weave Cloud, which is an application platform for Kubernetes. And what I mean by that is it helps you to do continuous delivery of your applications and then distributed monitoring of those applications. So essentially, it helps you to deploy your apps and then run them. And obviously, today I'm going to be showing that for EKS, and I'm going to be showing some integrations with EKS to make that monitoring much more straightforward. You might wonder why I think continuous delivery and monitoring is an important problem for us to solve in the Kubernetes world. And fundamentally, that's because although we've been talking about DevOps for a long time and we know that velocity helps us to deliver more reliably, the reality for many teams is they really struggle with this. So if we make more deployments, we increase the speed of our deployments, we decrease the size of them, that means that each individual deployment is less likely to be risky. So each individual unit of change is smaller and less risk-prone. That increases reliability because we can understand and reason about the change that we were doing much more easily. And if we do have an error in that change, we can reason and understand it, or we can even redeploy the previous known good state. But nonetheless, the situation that we're in for many teams today is that they do a few deployments a week or even a couple of deployments a month. And yet Kubernetes gives us some great opportunities to change that, to make the tooling available for developers and DevOps an order of magnitude better than it is at the moment. So ultimately, Weave Cloud, our management platform, is designed to help you with velocity and reliability. What are the current challenges in trying to solve that? The number one issue that teams face here is their whole risk of failure, right? You're going to do a deployment into production. You've collected together a large number of changes. It's difficult to reason about those changes. And then if you do that deployment and it fails, you're in a whole world of pain. And that's why we land up wrapping deployments with a lot of effort, process, systems to try and make sure that that doesn't happen. And fundamentally, a lot of the time, we land up with manual steps in our deployment. There's divergence between our development environments, our pre-prod environments, and our actual production environments as we log in to fix problems, solve issues, and so forth. And so ultimately, we want to have automation in that because it derives repeatability and it drives the speed of our deployment. And that's what I mean when I talk about continuous delivery. When I talk about reliability, things in the Kubernetes world are a lot better than we used to have in the past because Kubernetes itself helps us to deliver those services more reliably, right? It understands much more about the life cycle of those containers. It can do things like auto-scaling. It has an understanding of the health. But nonetheless, some of the things in the tooling are a bit lacking. We're now running quite a large distributed system. We might have external dependencies. So today I'm going to be showing an external dependency on RDS. So when we want to understand a problem, let's say that our login process has started getting a bit slower, we need to be container aware, we need to be Kubernetes aware, and understand exactly how that routes through the different layers of the software. And so observability is key to being able to deliver that reliability because it helps us to understand the problem and then find a resolution. And that's where Weave Cloud comes in. It fundamentally delivers continuous delivery automation and observability tooling. It's ops as a service, so we deliver it on-prem, or today I'll be showing you the SaaS service. And you can plug it into any Kubernetes, and today I'll be talking about Amazon EKS and showing an EKS deployment. If I drop down a slight one level lower, why is now a good time to improve velocity and improve reliability? Well, the number one thing is that Kubernetes gives us declarative configuration. So in a Kubernetes world, we specify exactly what the workload is and how it's going to run in the cluster, and we align that with the container. And then Kubernetes itself looks at that understanding that we've described and brings the system into accordance with that. If there's any divergence between that, then we know there's a problem in the way that we actually declared that service. So there's no longer are we logging in and doing some changes in our development cluster that we didn't do on another step, or trying to poke things in the production cluster. Because everything in Kubernetes is in YAML, we can store that in Git. That means that we get the advantage of when we do a deployment, being able to tag that deployment, understand exactly what happened. And the second advantage is we get to use all the development tools and workflows that we're used to in a Git world. So you can do operations by pull request. On the observability side of the house, we have some observability tools ourselves. And then, of course, the most important one here is Prometheus. If any of you know the history of Prometheus, you'll know that it's very container aware. It was written by a team of ex-Google SREs, so it's very orientated towards Kubernetes. It's fantastically flexible and has importers from a whole variety of different systems and databases. So enough talking, let's show you how it works. All right, so what we're looking at here is Explore, and this is a 2-node cluster that's running in Amazon. And what you're looking at in the edges here is the traffic from the internet to these 2 nodes. And then what you can see here is that the nodes themselves are attached to a monitoring system, so CloudWatch. And then we've also got a database server running here, and we're using Amazon's RDS for that. What are we actually running on this cluster? So the services that we're running, you'll see there's a front end and a catalog. If you've ever seen a Weaveworks demo, then you know that we always demo the sock shop. It's an e-commerce website. We sell socks as our secondary business model. So that's why what you can see here running in the cluster is a front end with a HTML, catalog with our different socks in it, including some premium ones available at Christmas, and our orders database and so forth. And what Explore helps me to do is to understand the relationships and the structure of my application and my containers actually within my Kubernetes cluster, right? So I can drop down, I can look at information that's running, how this catalog service is running. I can drop down into a container. I can attach to the logs, see those logs in real time. There's a lot of logs, lots of sales happening right now, clearly. I can attach directly to a container and just perform normal administration, but just super simple to do and gives me a variety of views and aspects about how Kubernetes is running and what it's running, the workloads that it's running. How did these services get deployed? All right, so now I'm going to show you a deployment. This is my front-end service. And as you can see, the current version that's running, this is a container that was built and put into a container registry, so into a Docker registry. I think this is the Amazon registry, AWS registry. And there's a new version that was done 3 months ago. So I'm now going to release that new version. And this is the first place where I can join up the kind of deployment part with observability. So I'm going to switch the Prometheus metrics to using red metrics, which I defined earlier. And now I'm going to do a deployment. And I'm going to switch from the old version to the new version. And so it's synchronizing to the cluster. It's waiting to sync. It's hopefully syncing. There we go. It's done a manual commit. And then it's synced that and done a manual deployment into the cluster. So when I say that it's done a commit, what do I actually mean? And what I mean is that I've got a definition here for the service which is running in the cluster, and I've switched from the old container tag to the new container tag. And what's important to understand here is that this is the YAML file for this service running in the Kubernetes cluster. So whilst I showed you changing a container, I could change some of the resource requirements for this service. I could do it as a pull request. I could do some comments with my colleagues. And then when I pushed it, WeaveCloud would automatically deploy that into the cluster for me, right? So it automates the whole deployment process. And when I say it's in Git, what I'm looking at here is all the workload definitions, all the YAML for this particular cluster. So it's a different Git repo from the Git repo that you use for your source code for those services. This is specifically defining all of the different workloads. All right, so I've done my deployment. It's operating, and you can see the impact that it's having. So I probably want to keep an eye on this before I go to lunch. But let's say that I just want to have a general understanding about how my workloads are performing in production, right? How are all of my services doing? And so this is showing me basically all the workloads that we've automatically detected, and then we build a set of dashboards for the user, pulling out all of the standard Prometheus metrics for them. And because I'm doing a demo, I can't find front end because I can't spell. But now I've got the front end, so this is the kind of a central view of front end. It gives me some information about the deployment. And then I automatically get the dashboards for this. So again, you as the developer don't have to do anything. You as the DevOps team don't have to do anything. This is just built automatically for you. And you can see the relationship here between this deployment and then what's happening. And I probably want to keep an eye on this to make sure that that's just a temporary drop in the CPU usage, or is something bad happened with that deployment. More widely, when I'm doing things, I can also look at monitoring for the whole of my cluster. So this is the whole of the cluster, and then I can look and dive down into the cluster by namespace. So this is SockShop automatically. And this is pulling out all of the Prometheus stats. And then the last thing I wanted to show you is because we're often building services which have external dependencies. So in this case, we're using RDS for the SockShop. And so again, it automatically detects that I'm using RDS and builds a set of dashboards for me. So that's a bit of a whistle-stop tour through the whole thing. I hope it showed you the key benefits of being able to bring continuous delivery and observability together into one unique experience. And if you'd like to give it a try, you can find it at weave.works. Thank you. There you go.
Thank you. So I have two questions.
Sure.
One of them is an actual legitimate question, and one of them is a silly question. So the legitimate question is, so you mentioned so you can automatically deploy this way. Can I also fit testing into my workflow through Weave Cloud?
Yes, you can. So you can basically use one Git repo for each of your environments, and then use a pull request process and a merge process to move those changes between different stages in your deployment pipeline.
Gotcha. And my silly question is, well, this is actually it's extremely serious business. Or is there any actual iteration of the Weave sock shop in which I can actually purchase socks?
No, you have to become a special customer of ours to get the special edition socks.
That is savage. Thank you for joining us. This concludes our workshop-y demo coverage, but it's lunch now, and then the actual workshop will resume at 1:30. So just about an hour from now, we'll be back in here with a workshop. So thank you for coming this morning. Lunch is that way.
Thanks, everyone. Thanks to our demo.